Good morning, grade 7 learners. Welcome to another fun and interesting science lesson. But before we start, let me give you these important reminders. First, prepare your module and writing materials. Second, focus and listen attentively in our discussion. And lastly, participate actively using the comment section. For our most essential learning competency, you are expected to distinguish mixture from pure substances based on a set of properties. As for the specific objectives, we need to classify pure substances as elements or compounds and distinguish the properties of mixtures and pure substances. And now, what are we all waiting for? Let's begin and have an exciting and enjoyable learning. On the previous discussion, you've learned about elements and compounds in food data. But today, we will learn another exciting and fascinating topic under the classifications of matter. During your elementary days, you described matter as anything that occupies space and has mass, and identified according to their states as solid, liquid, and gas. And as a matter of fact, we are all surrounded by matter, right, grade 7 learners? Remember that matter can either be classified as elements or compounds, which are also known as pure substances. What is a pure substance? Well, that's what we need to discuss further in today's session. Before we determine pure substances from mixture, let's look at this diagram. As you can see, pure substances are classified as elements and compounds. To check your prior knowledge about elements and compounds, let's try this simple game. And let's call it Your Out. In this game, you will simply choose which of the given samples does not belong to the group. You will only be given 10 seconds and don't forget to type your answer in the comment section. Are you ready, learners? Which does not belong to the group? Is it water, grass, oxygen gas, or sugar? Your time starts now. Time's up. The answer is oxygen gas. Very good, grade 7 learners, because oxygen is an element while water, grass, and sugar are compounds. Next, titanium, sulfuric acid, mercury, or silver. Your time starts now. Time's up, learners. The answer is sulfuric acid. Very good, grade 7 learners. Sulfuric acid is a compound, while titanium, mercury, and silver are elements. Let's try this one. Helium, salt, carbon dioxide, or vinegar, which does not belong to the group. Your time starts now. Time's up. The answer is helium. Very good. Helium is an element, while vinegar, salt, and carbon dioxide are compounds. And lastly, which does not belong to the group? Is it pure gold, water, methane gas, or baking soda? Your time starts now. Time's up, grade 7 learners. The answer is pure gold. Remember that gold is an element, while water, methane, and baking soda are compounds. Great job, learners! As I have said earlier, matter can be broken down into two categories, pure substances and mixtures. The question here is, how pure substance differ from mixture? Let's find out as we go through our discussion. I have here two samples of liquid substances. If I put these substances in the glasses of wine, can you identify which contains a pure substance and which one contains a mixture? I know. I know what you're thinking, learners. Yes, just by looking, it's very hard and difficult to tell. But how can we really determine which one is a pure substance and which one is a mixture without tasting them? Very interesting, right? Actually, there are different ways to distinguish pure substances from mixtures. Pure substances are made up of identical particles and they have definite set of properties. All the particles of a pure substance are the same throughout. Look at these gold bars. We can say that this is an example of a pure substance because it is made of identical particles. When we look on its compositions, we can see that it's made up of only one type of atom, which is gold. We also notice that there are no other particles added. Moreover, even if we cut the gold into pieces, its compositions remains the same. Remember that gold is an example of element? Therefore, the 118 elements listed in the periodic table are all pure substances. Can you name other examples of elements? Just type your answer in the comment section. Another type of pure substances are compounds. Compounds are made up of atoms with two or more elements that are chemically combined in a specific ratio. And these compounds cannot be separated physically. Let's take the water as an example. To form this compound, water needs a combination of two hydrogen atoms and one oxygen atom, or commonly known as H2O. All compounds are bonded chemically, that's why we cannot separate them by physical means. To separate oxygen and hydrogen in the water, it requires chemical processes. The process that separates hydrogen from oxygen is called electrolysis. It works when chemical changes occur and the presence of electricity is supplied. To give you an idea on how electrolysis works, let's watch this video.
In that small plastic container are two metal push pins, and they're inserted a distance that's between the positive and negative lead of the 9-volt battery. So you just insert them in there and make sure that they're that distance apart, and that should be fine. In the container is going to be some water that has baking soda mixed into it. The baking soda in the water allows electricity to flow between the two metal tips of the push pins. And so now you set them on the leads and the electricity can flow between the two push pins now. And so electricity is flowing through the water, and so that's enough energy to break apart the water, make it undergo a chemical reaction so that the H2O gets broken apart into H2 and O2. It's going to be hydrogen gas and oxygen gas. And both gases are going to flow up through the test tubes, and one of the gases is going to be in one test tube and the other one's going to be in the other one. How do you know which one's which? Well, if you take a look at the amount of gas in each test tube, there's going to be twice as much hydrogen gas as oxygen gas. So you can see in the right test tube you have twice as much hydrogen gas as oxygen gas. This is how experimenters first learned that the ratio of hydrogen atoms to oxygen atoms in water is 2 to 1. It's 2 to 1 ratio, thus H2O.
To find out which one is oxygen gas and which one is hydrogen in the test tube, you need to do the sprinkler test. And for another example, we can say that salt is a compound because two or more elements are combined chemically in a specific ratio. To form this compound, element sodium participates in the chemical reaction with chlorine to form substance like sodium chloride, or also known as table salt. Here are the other example of compound that may be found at home. We have sugar, baking soda, and hydrogen peroxide. Another property of compound is they have fixed melting point and boiling point. As an example, water boils at exactly 100 degrees Celsius. This will not change unless you add other substances and find impurities or undissolved particles, just like in our example. We have two different substances, one with pure water and the other one contains impurities or undissolved particles. Now, can we still say that the glass with impurities is still pure substance? What do you think, learners? Yes, you're right. It is no longer a pure substance because it is now a mixture. In contrast to pure substances, mixtures are made up of non-identical particles. As an example, we have here salt water solution. This salt water solution is an example of mixture because it is made of two non-identical particles. When we look at their compositions, water is made up of hydrogen and oxygen, while salt is made up of sodium and chlorine. Therefore, the composition of salt water solution is made from two different substances. This is also the same with the mixture of water and oil. Unlike pure substances, mixtures are not chemically combined. They are combined physically, and the substances combined retain their original properties like in water and oil. Water is still water, and oil is still oil, meaning there are no other substances formed. The other examples of mixtures we have halo-halo, milk tea, and air, which are present everywhere. Mixture also do not have definite set of properties. They came in different proportions and they don't have fixed ratio. Meaning, it depends on the person who made or prepared the mixtures, just like you're doing a coffee blend. You can add more coffee powder or granules or more sugar. It really depends on the taste of coffee you like. One more thing is that mixtures don't have fixed melting point or boiling point. The temperature of melting and boiling point of the mixture depends on properties of combined substances. On the other hand, mixtures can be separated physically or by using other techniques in separating mixtures, like sieving, filtration, hand picking, decantation, the use of centrifugal machine, and filter chromatography. These are some of the examples. When we say mixtures, it does not always involve solid and liquid, just like in salt water solution. Mixture can also be a combination of solid and solid, like mixed vegetables. Liquid to liquid, like vinegar and soy sauce. Gases to gases, like air, and a combination of liquid to gas, like sodas. In this example, we can say that mixtures can be in different forms. And now, to see if you learned a lot today, let's try to answer these activities hidden inside the mystery box. In our first activity, you just have to click the happy emoji if the statement is correct, and click sad emoji if the statement is incorrect. Are you ready, learners? Number one, an ice block is a mixture. Is it sad face or happy face? The answer is sad face. Good answer, grade 7 learners. Next, we use filtration to separate a mixture of solid and liquid. Is it sad face or happy face? The answer is happy face. Very good, learners. Next, for number 3, a water can be separated through electrolysis. Is it happy face or sad face? The answer is happy face. Good job, learners. Number 4, I make a mixture if I combine two sodas. Is it happy face or sad face? The answer is happy face. Very good, grade 7 learners. For the last number, Aluminum is a pure substance. Is it happy face or sad face? The answer is happy face. Job well done, grade 7 learners. And now, let's try the second activity. And for this activity, you just have to choose the letter of the correct answer. For number 1, all elements found in the periodic table are said to be blank. A. Solution. B. Mixtures. C. Pure substances. Or letter D. Compounds. The answer is letter C. Great job, grade 7 learners. Next, a mixture of carbon dioxide, nitrogen, oxygen, and water vapor is called blank. Is it A, dirt, B, air, C, compound, or element? The answer is letter B. Great job, grade 7 learners. Number 3. This is made up of one or more of the same kinds of atoms. Is it A, mixture, B, matter, C, compound, or element? The answer is letter D, element. Great job, grade 7. Next, which of the following would create a mixture? A, stirring a container of water. B, heating a sample of salt. Letter C, adding sand to gravel. Letter D, filling a beaker with ice. The answer is letter C. Keep it up, grade 7 learners. And last, which of the following is always true about mixture? A, made of two or more materials. Letter B, heavier than the other kinds of matter. Letter C, a solid always combined with a liquid. And letter D, impossible to separate. The answer is letter A. Job well done, grade 7 learners. And now, let us summarize what we have learned today. We often classify matter as solid, liquid, or gas. But there is one more interesting way to classify it. Remember that matter can be broken down as pure substances and mixture, and both of them have their own properties. For pure substances, they are made up of identical particles, they have definite set of properties, they all have the particles that are the same throughout, they are made up of atoms of two or more elements that are combined chemically, and they cannot be separated by physical means. While in mixtures, they are made up of non-identical particles, they don't have definite set of properties, they are made up of two or more substances that are combined physically, they can be separated by physical means, and they don't have fixed melting point and boiling point. I hope you have learned something on our discussion today. And at this very moment, I will be reading 3 questions from the comment section. First, from Bignay National High School, what are the examples of pure substances that can be found at home? Aside from water, table salt, sugar, and baking soda, we also have jewelries made from gold or silver that are said to be elements, and diamond, which is also a pure elemental carbon under extreme heat and pressure deep within the earth. From Paso de Blas National High School, how can we easily tell that an object or material is a pure substance or a mixture? An object or material is a mixture if we can separate them physically or by using techniques to separate them. For instance, halo-halo, sugar solution, and air can be separated by physical means. On the other hand, materials are said to be pure substances if they cannot be separated physically, and if it consists of only one kind of atoms or particles, like silicon, neon, vinegar, and baking soda. From Kanumali's National High School, pure substances and mixtures are matter. Aside from this, what are the other similarities of pure substances and mixtures? Well, both of them have mass, weight, volume, and color. They both have points at which they boil and solidify. So, I hope I have answered your questions, and for those that I wasn't able to entertain, you may address your question to your subject teacher during your follow-up discussion. Again, thank you and God bless us all. Keep safe, everyone.